Welcome to Painting with the Scientist. In today's episode, we are going to be painting a Carboniferous forest. The paints that I am using are acrylics, but you can use any paints or colored pencils or markers that you would like. You can also print out an outline if you would like to print out the same outline that I am using and then have that be your guide, or you can paint along freestyle. It's completely up to you. I did post a link in the description and in the comments to the Patreon page where you can download this. It's a free download. And again, totally up to you if you want to paint along using that, or if you'd like to paint freestyle. We will be using a lot of blues, greens, and browns today because we are painting, excuse me, we're painting a scene from a forest. Carrie says, love the hair. David says, Bob Ross vibes. Thank you, you guys. And welcome to everyone who is watching live. I see a question, do we need a pencil? You don't need a pencil. It's completely up to you. My approach with art is that art is a very fun and laid back space where it is completely okay to make mistakes. It is okay to color outside the lines, and it is okay to take something and then go your own direction with it. I'm painting a Carboniferous forest and I have an outline for you, but if you get inspired to add a fantastical element into your forest, like say you want to know, you start thinking about like, what would it look like if this dragon was here? You can paint a dragon. It is totally up to you. I'm undoing a couple more caps here so that then my paints are going to be all ready to go. And then on my palette, the first thing I'm going to do is mix together some white and some blue, because we're going to start with our background, and I want to have a nice light blue sky up top, and then fairly quickly we're going to get into the greens that's going to be our background. The Carboniferous got its name because so much of our coal and the oil deposits that we have, but especially our coal, so much of it comes from this time period in Earth's history. It was more than 300 million years ago. From about 300 million to about 360 million years ago, that's the time period for the Carboniferous. And it was a time where plants just exploded. And there were so many types of plants. Several of them were really unusual, and we're going to paint 3 of them today. But first, I've got to get my water and my brush. I have one brush here that I'm using because I only have one paintbrush in my house. And the motto of our quarantined life is just make do with what you have. Quick, do we have any? I have a couple YouTube friends who have moderator powers. I'll just say hello real quick to people who are in the chat and see if any of them are there. So hello to Pixelbit and Pearson. Hey, it's Corgi123 and Maria, Queen Jane, G-Man, Duck King, Shannon, Nikki, Crystal. Good to see you guys all here. And I will bring the board closer. Yeah, thank you, Vivian. So you get to see me and my lovely blue wig right at the beginning, but then typically I bring this closer so that you have a good view of our painting. All right, let's start off with our background. We are going to be painting a light blue sky, and I'm going to get my brush nice and wet so that I make this blue paint last as long as I can, because I'm getting a little bit low on the amount of white paint I have. So I'm going to mix around and get a nice blue here, add in just a little bit more blue because I want it just a little bit darker. And then we'll start with our background. And my light blue background is just going to take up maybe like the top 1/5 of the page. I'm not going to paint all the way down because our Carboniferous forests were fairly dense. There were a lot of plants. And so for the most of this background here, I'm going to want to paint that green. But we do want some sky up here at the top. So I'm going to come in around these trees here and just paint some nice blue sky. Now, the first thing that you should know about the Carboniferous is that the atmosphere was different. We have about 21% oxygen right now on Earth. And during the Carboniferous, the oxygen content was 35%. Whoa! That is significantly higher than 21%. And because of that, The Carboniferous was the age of the giant insects. And we'll talk more about each of the insects that we have drawn here. But just to give you sort of an idea, a quick preview, you had dragonflies as big as pigeons, where when their wings were outstretched, they were a good 1.5 feet across. You had flies as big as canaries or finches. So the insects, the flying insects, were the size of birds. There were no birds yet. The birds had not yet come on the scene. And there were really no dinosaurs yet either. You had giant insects and you had a lot of plants. And that was the main makeup of our Carboniferous life scene. We had lots of insects. We had the beginnings of reptiles and birds coming on the scene throughout this 60 million year time frame. We started to get some animals that could lay eggs, which was a real big deal. But at the beginning, it was really just insects and plants. And now that we've put our blue sky in, I'm going to mix in some green to kind of paint like our backdrop. And I'm just going to make it mostly a light green going all the way through, because we'll be painting our trees that are closer in a few minutes. Duck King asks, are dragonflies dragons that are flies? That's a great question. Dragonflies are not dragons that are flies, but I like the name because they definitely have dragon-like qualities. So dragons are a mythical creature that are fierce and aggressive, and so are dragonflies. Dragonflies are actually kind of like the top of the food chain quality when it comes to insects. They are predators, they can go really fast, and they eat other insects. So if you've ever been outside and you've ever been bothered by mosquitoes, like, oh man, so many mosquitoes out here. If there were more dragonflies nearby, there would not be as many mosquitoes because the dragonflies would eat those mosquitoes. So dragonflies are nice to have around for that reason. And I see someone recommending Wings of Fire by T. Sutherland. I definitely like T. Sutherland's books. The Menagerie is one of hers that I've read, and that's a favorite book of mine. That's a great one. All right, I've got my green ready now, and I'm going to paint my background. And what I'm going to do to try and make it look sort of more foresty is I'm going to paint in strokes sort of going up and down rather than going side to side. And then once I get all the way through with this green, I'm going to add a little more of a different green to it so that the color looks a little different, and then kind of fill in. And that will help it to look like this is the background of our forest, that we have other trees that are back there, but we just don't really see them because there's not as much detail. And I don't worry too much if I'm going over the lines of some of these trees accidentally, because when I come through for our trees that are in the foreground, I can just paint over it. Now that I've got my first layer with this green, I'm going to come back to my palette and I'm going to take just a little bit of blue, mix it in to give this green kind of a different color, and then we're going to go through again. Nice little strokes. Kind of top-down direction. Get just a little more paint for over here. And then as the paint is starting to be, not as thick on my brush, I'm coming up to the top to try and blend in with the sky. When your brush is almost out of paint, that's a really good time to get in some of these areas up by the sky and up by the edges of the trees, because then it's pretty light and you'll be able to paint over that easily. And now that we've done that, I'm going to mix in a little bit of brown with my green. So I'm going to take a little bit of this brown, mix it in right here. I just want to get enough to get on my brush so that I can do one more pass through here with a brown that's a little more of an olive brown. Or sorry, not a brown, a green. A green that's a little more of an olive green. During the Carboniferous, I mentioned before that the oxygen content was 35%, and that is way higher than we have it now. And a lot of times we think of oxygen as just being good. Like, yeah, oxygen's great. The more oxygen, the better. Well, that's not true. Too much oxygen is a bit dangerous. If you have high oxygen content, things are going to rust easier. Like imagine, you have a piece of iron that is left outside for a machine or something. You know that iron will rust eventually. Well, it's going to rust a lot faster and a lot worse if the oxygen is higher than it will if the oxygen is lower. And you can sort of think of your body as being a little bit like that iron machine, where your body needs oxygen to function naturally. But if your body has too much oxygen, that can cause problems. And with our insects, we think that part of the reason these insects got so big was just to try and protect themselves from the oxygen, because when those insects were larvae, that much oxygen can actually be too much. And if they were bigger, then they were able to handle that oxygen a bit better. And another reason that they were able to get so big is because insects are very different than us. They don't have lungs. Insects have what are called spiracles, little tiny holes on the side of their body, and each of those little holes is attached to a tube that goes into the body called a trachea. I'm going to get some different green now and paint this sort of the grass here on this like groundy area, and then we're going to do the trees. But while I'm painting the grass, I'm going to tell you more about insects and how they breathed back in the Carboniferous when they were so big, because it's really pretty cool. Well, and it's how they breathe now too. So if you've ever looked up close to a grasshopper, if you look at the mouth of a grasshopper and you watch them really closely, you're not going to see them opening and closing their mouth, breathing through their mouth, because grasshoppers actually breathe through the sides of their body. They breathe through these little tubes called spiracles, and then those little openings are attached to these little trachea, and that's how a grasshopper breathes. Well, if your oxygen content is only 20%, and that's what we have right now, that puts a limit on how big an insect can get. Insects really can't get much bigger than the largest size that we see now, which is about like that big. That's about the largest an insect can get. But if you increase the oxygen content, then you can have insects that are, I'm trying to get in the view, this big as pigeons, as big as, fairly large birds. Insects got that big in the Carboniferous all because there was more oxygen, and that allowed them to be able to breathe and have it get all the way through to their interior. If you tried to build an insect the size of a dinosaur, it wouldn't work, even with 30% oxygen, because there's no way that the oxygen gas would be able to get all the way into the body, traveling through those little trachea. And that's really, that's why we have lungs. You have lungs because you need oxygen. And if you just had a hole and you didn't have things expanding and contracting to pull the air in, you wouldn't be able to get enough oxygen. And that's all insects have. They just have those little holes. They don't have lungs like we do. So that puts a limit on how big they can get. If you've ever seen a science fiction movie where there was like a giant ant the size of a house, you can rest assured knowing that could never, ever happen. Not unless you made it not an insect anymore. You could have an animal that looked like an ant, but it has to have lungs to be able to get enough oxygen. Another cool fact about the Carboniferous is that during this time, there were no seeds. So when we have plants make seeds, right? If you've ever planted a garden, then you've been planting seeds in the ground, and those seeds sprout and start to grow. But in the Carboniferous, there weren't any plants that had seeds. So then the question is, well, how did the plants reproduce? How did you get new trees and new ferns and new mosses? How did you get new plants? And the answer is with spores. All of these plants that we're drawing today, they all reproduced using spores, not seeds, which is really pretty cool if you think about it. So they were very different than the plants that we have and the trees that we have today, but they were somewhat similar to several different species that we still have around. that we'll be talking more about in just a minute. I'm almost done now with my grassy area, although I shouldn't say grass because there was no grass like the grass we have now during the Carboniferous. So this ground cover that I'm drawing here that's all over the ground around this pond and around the trees, this is all moss. During the Carboniferous, we had a lot of moss, different types of moss. We had a lot of ferns, and I didn't actually draw like an outline of a fern leaf, but what we're gonna do right now is get a darker green, and we're gonna add in some ferns. So here is a little bit of a darker bluish green. And I see Meyer Katie asks, Science Mom, how do you know everything you know? So I am not a paleogeologist. So last night I did a lot of reading about the Carboniferous. And I will say, if there are any paleogeologists watching, anyone who specializes in the Carboniferous, if I make a mistake and say something that's not right, I definitely want you to tell me in the comments, because I had a lot of fun learning about this time period, but I'm definitely not an expert. But most of what I know, I learned through reading, and I love to read. Here's a fern, and then I'm going to draw several more ferns. Ferns have they have their fronds, and they have stems and a base. So I'm going to draw kind of the stems first here, and then on the side of the stems, I'm just going to go dab, 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 dab with my brush to try and make it look like those fronds of the fern. Get a little more paint and do another fern here. And another fern leaf here. There were tree ferns during the Carboniferous as well, and we still have tree ferns around today. Tree ferns are a really ancient species that have been around for a long time, and there's several different varieties. You find them in Australia and in Hawaii. They are beautiful, beautiful plants. And there were some of those back in the Carboniferous as well. We'll do a few more kind of fern-like things over here. And then we'll be ready to start on our first plant. Our first tree, I should say, because we've already drawn lots of plants. But we'll draw our first close-up of the tree as soon as I finish some of these ferns. And if you want to do more ferns, you definitely can. You can put them anywhere you want. All right, now it's time for our first tree, and our first tree is a lycopod. Lycopods were one of the dominant species in this in this Carboniferous forest. And the lycopods are also called scale trees because their bark looked kind of like the scales of an animal. In fact, a couple of the very first fossils that were found of lycopod, they thought that they had found a reptile when they found just this cylinder-type hunk, and it had this diamond-shaped pattern on the outside. They actually thought that it looked like it could be a reptile. But it's not a reptile. The lycopod is a tree, but it's a really cool tree because the lycopods, they had these leaves that would kind of come out. Oh, and this brown is ending up a little darker than I wanted, but that's okay. So I'm going to use this dark brown to try and kind of do my stripes, and then I'll try and come back through with a lighter brown for the underneath, which is completely backwards. If you have not yet started on your lycopod tree, I recommend doing the light background first and then doing the dark stripes, because that will work out much better for you. But that's okay. Once we get started with something painting, we just go with it. And so I'm going with my backwards approach of painting what's in front first. It's always better to paint what's in back first. But if you make a mistake and forget like I did, just give it a try and see how it turns out. So as I was saying, the lycopods were tall trees. They could get up to 100 feet tall. They were enormous. They grew quite quickly, and they had leaves that would come out directly from the trunk. And after the leaf fell off, then you would end up with this diamond-shaped scar where the leaf was. And then after that leaf fell off, you would end up with this pattern on the trunk, this kind of crisscrossed pattern. So they had really cool bark. And then up at the top of the lycopods, and this is another lycopod here, you would get these kind of broad leaves that would hang down. And then instead of flowers or seeds, there were no flowers at this time. And during the Carboniferous in Earth's history, there was not a single flower, there was not a single seed. None of the plants had seeds, none of the plants had flowers. What you had instead were cones and spores. So the lycopod would develop these little cones at the end of the branches, and then those cones would open, they would release spores, and the spore is kind of like a seed, except it doesn't have a coating. It can't survive as long as the seed, most likely. These spores couldn't survive as long, and it needs to be in a wet environment. And so this is why these trees did so well during Carboniferous, because the climate was very, very wet, and there was a lot of water. Now, once it's thought that these trees were monocarpic, and that means that once they flowered, they died. So you would have a big lycopod that would grow, and then once it produced these cones and made spores, that was the end of its life, and it would fall down and die. And I saw someone in the chat asking, did lycopods have roots? They did. So we've got these sort of the top part of these roots going into the soil, and they actually had some really cool patterns on their roots. Probably they might have had like little sprouts kind of coming out the top of their roots even, we're not entirely sure. But once a lycopod died, then the trunk would fall to the forest floor. And here is something really cool about the Carboniferous. I'm going to paint sort of brown for the bottom part of this trunk. And for this trunk, we're not close enough to see all the detail from the crisscrosses. So I'm not going to try and do crisscrosses. I'll just paint the bottom part of both trunks, and then I'm going to add a little bit of a lighter brown to my paint and paint the top part so that they look sort of like this is part of shadow. Now the lycopods, when a trunk would fall to the ground, it would not decompose the same way that things will decompose now, because the funguses that were alive at this time, they hadn't figured out how to break down things as well as they have now. And there was not any animal that could eat the trunk, and there was not any fungus that could break it down. And so every time a lycopod grew and then fell, you would have the trunk just sort of hanging around, not really decomposing, and you ended up getting these huge areas that were full of all this material, the old lycopod trunks, the old lycopod branches, and that caused a huge amount of carbon that was in the atmosphere to get all locked up into this plant material. And so the amount of carbon in the atmosphere started to drop, and the amount of oxygen had increased a lot. We said at the beginning it had gotten up to 35%. So the lycopods were actually the main reason why we had a huge change in climate near the end of the Carboniferous. And the oxygen content got so high and the carbon content got so low that we started to get seasons. This is so long ago that instead of having the continents in the place where they are now, we had a supercontinent called Pangaea that was coming together, and the world was entirely tropical. There was not winter and summer and fall like we have now, and there were no seasons, but the lycopods changed all that. They took up so much carbon that we ended up with not only seasons starting, but we also got the first ice age. Now I'm going to use this brown here to paint the other trunk of our lycopod, this one that's here in the background. And then I'm also going to use a little bit of brown for these cones here, because this lycopod is getting ready to release its spores and complete its life cycle. But I bet you're wondering, so this is what a big lycopod looks like, but what about a small lycopod? What about when they were small? Well, they actually had a really cool appearance when they were small. And they looked kind of like Joshua trees. If you've ever seen Joshua trees, they are a tree that grows near where I live in Las Vegas, Nevada. And they look kind of like bottle brushes. They have a trunk when they start out, and that trunk goes up, and then they have green leaves sticking out everywhere. And that's sort of what these lycopod trees looked like when they were young. And then as they got taller, all those leaves that were on the side would fall off, and then the leaves would just stay on the top. And now that this paint has dried a little bit, I'm going to come back and I'm going to just paint over real quickly to try and keep that nice sort of striped appearance for the bark, that diamond-shaped pattern on the bark. And if you feel like I'm going too slow or too fast, you can always adjust the speed yourself. Since this is a video, that's one of the nice things about video. You can pause it and wait till you catch up, or you can skip ahead if you have already completed coloring all your trees and you want to get closer to the end. You can always set the pace. And I saw a good question asking what would happen if there were no insects. If there were no insects, that would be a pretty disastrous thing for us. Or what would happen if there were no grass? If there were no grass, then I bet there would be other plants that would come up to sort of fill the gap. But without plants, life on Earth would come to a complete stop. We have to have plants, absolutely. And during the Carboniferous, plants really were the dominant life form on Earth, plants and insects. This was the age of the giant insects and the age of the seedless plants, because again, none of these plants had seeds. They reproduced using spores. And ferns still do reproduce this way today. If you have ferns in your yard or see ferns out in the wild, you will never see a fern with a flower because they don't use flowers to reproduce. They use spores. And on the underside of a fern leaf, sometimes you'll see these tiny little circular brown dots. Those are spores getting ready to drop. And I see, hey, it's Corgi asks, do we post pictures? I don't share, I haven't been sharing pictures of painting with a scientist on quarantine, but I could share some on Friday, because we're going to do painting with a scientist on Fridays and Mondays. But there's a link on Facebook where you can post them, or you can share them on Instagram and tag me and I will see them. All right, so here are our lycopods. We have this close-up of a trunk. We have our tree there. We have our little small lycopod trees. And then we have the trunks that have fallen, and they're just fallen and they're staying there because the fungi have not yet figured out how to decompose this material. But I bet you're wondering, was the lycopod trunk made out of wood? Well, it depends on what you call wood. They did not have xylem and phloem and growth rings like most trees have now. Their structure was more similar to that of a palm tree or a Joshua tree, where on the inside you have pith, and on the outside you have this real thick protective layer that's made from the old leaves. But they didn't have growth rings and wood like the trees that we have now do. But even though they weren't woody trees, they still were strong enough to grow hundreds of feet tall, and they were tough enough that the fungi that were alive then could not digest them. All right, I'm making the branches now on the outside of our baby lycopods, our juvenile lycopods, and then we're going to paint the top crown of this lycopod. It's really sort of cool to me to think that this single plant species changed the climate of the entire planet and brought about the first ice age. And it did it just because it was so good at creating those trunks, and also because there wasn't balance yet between the producers and the consumers. Plants are producers. They take carbon and turn it into a form that we can use. And then us, animals and fungi, mushrooms, fungi are the consumers. They consume what the plants make. And the consumers, the fungi, had not yet caught up with the plants. They hadn't figured out what to do with all of this trunk material that was being made. And because of that, we had massive production of carbon, capture of carbon going into these trunks. And then the bogs and the wet areas where all these trunks fell, They turned into peat moss, which then later turned into coal. And the coal reserves all around the world come from this time period. All right, our lycopods are all done. Now it's time to move on to plant number 2, which is a really cool one called Calamites or Calamites. And this is sort of like, looks a little bit like bamboo because it has segments, but it's related to the horsetail plants. If you've ever seen the horsetail plants, they look kind of, they're small. These ones were big. These ones could get up to, 50 feet tall or taller. But the modern horsetail plants we have are a lot smaller, but they do have these segments. So we're going to come down and paint our horsetail tree here. You can call them horsetail trees, but that is not their correct name at all. Their name is Calamites. They were tall as giant bamboo is today. And then from every single segment, you would have these leaves coming out. So I'm going to paint this one right down the middle, nice and green. And then I'm going to add a little bit of brown to my green because I just want the color to be a tiny bit different. And I'm going to mix it in. And we're going to paint these leaves coming off the side. And we're going to paint this cluster of new growth and leaves up at the top. And then we're just going to go sort of whoosh. Everywhere there's a little segment there, we had these sort of branchy leaves coming out. We'll get a little more paint to finish that off on the other side. And I have to say, if I could go visit any forest at any point in Earth's history, I would definitely pick the Carboniferous. I think it would be so fascinating and amazing to see. And then when these got big enough, sometimes they would have branches where these branches would droop over and hang down. So I'm going to draw a little bit of brown, greenish brown coming down from the top of this one. Seeing the Carboniferous would just be amazing. And I see someone in the comments saying, but the bugs, what about the bugs? Well, the bugs were, for the most part, to us, would be friendly. There were no other mammals. This dragonfly was the top predator in the food chain, but it would not have tried to bite you. It ate other insects. And so you would be safe going through a Carboniferous forest. None of the animals there would bother you, I don't think. Not that I've been there to tell the tale. So there's our Calamites. And now the last plant that we're going to paint is called Sigillaria. And the Sigillaria, we actually have evidence that their trunks were photosynthetic. And so I'm going to paint the trunk of this one a light green, but we have so much green here, and I want to try and just give it a different hue. So I'm going to add some white here and mix up this green. And then I think I may mix in just a little bit more brown as well, so that we get sort of this unique pastel-y color, just so that these trunks stand out and don't get lost in the background. No, never mind, they're totally getting lost in the background. That's all right. We'll just go with it. We'll add a little more green. I'm going to make this nice and thick. All right, they're like camouflage trees, right? You can hardly see them. So this Sigillaria trees that are totally blending in with the colors of my background, and my newly named camouflage trees, they are similar to the lycopods in that they reproduced making these little cones. And they also just had, the branches would start out on the trunk, and then they would fall out as the tree got taller. And then they would have these beautiful long blades of, that looked kind of like grass out the top. So I'm going to just sort of paint my little spike here of my tuft of leaves. And then I'm going to do another tuft of leaves here. And then we're going to paint the leaves on top of this other Sigillaria up here. And they're cones. So the cones on the lycopods came at the ends of their branches, but the cones on the Sigillarias came from the trunk. So we'll get a little bit of brown and light brown, and we'll draw our cones hanging right from the trunk here. And we're not sure if these ones were also monocarpic, if they, died as soon as they produced cones or not. They might have been able to produce multiple cones. It looks just kind of like a donut around my trunk now because my cones sort of blended together, but that's okay. And now last we have our 2 animal species and our pond. Let's do our pond real fast. I'm going to put a little bit more dark blue into what I used for my sky and add a little bit more water so that hopefully it's not too dark. Now the cool thing about water is that water changes color depending on what it's reflecting, on what's above it. If you notice, if you look at the ocean on a cloudy, overcast day, it's going to look kind of gray. And if you look at the ocean on a sunny day, it looks very blue. Well, if you look at a pond in a forest and there are trees all around, it's going to look a little green. Not just because there might be algae in it, but because it's reflecting that green color from all the plants around it. So I added just a little bit of green to my pond water as well. And now we're filling in. There was a lot of water and the planet was very warm during the Carboniferous. So you definitely had scenes like this where you'd have trees and a marshy area. And I'm realizing that I did not get nearly as close back here in the back. I've got quite a bit of white here, so I'm going to just take my brush that's a little bit dirty and fill in that a little bit. And now we're ready to talk about our animals. Oh my gosh, you guys, these 2 animals are so awesome. So the first one that we'll talk about is, Meganura. Meganura is our giant dragonfly. It's so big that if I had one right now and I was, let's say that I had a Meganura and it was a nice friendly dragonfly and I let it land on my shoulder, it wouldn't be able to fit on my shoulder because the wings would be too big. So then if I tried to just hold it on my hand here, the wingspan would be wider than my shoulders, just barely wider than my shoulders, which is amazing. That tells you just how huge this insect was. Now, just for fun, I'm going to get some purple, a real light purple, and some blue for the wings, because I think it would be fun if we kind of had like an iridescent sort of rainbowy look to our wings. And for the wings, I'm going to try and just kind of stripe out with real light strokes, because I think they'll look more realistic if they're mostly white. I'm pretty happy with that. That looks good. So there's our wings for our dragonfly. And in real life, we have dragonflies that have amazing, beautiful colors. Oftentimes, insects will develop beautiful coloring to help them attract a mate when it's time to lay eggs and breed, or as a display to sort of fend off rivals. Whoops, my finger stuck to my tree. So I'm going to paint this insect a real pretty blue color. And then if I can get a little more purple on my brush, we'll add a little bit of purple too. A little bit of purple up here in the head. And kind of along the body. And then for the eyes, some silvery color would work well, but I don't have any silver, so I'm just going to get a little bit of this brownish water and sort of paint the eyes a little brownish, and that works well. So there's our Meganuria, which, like we said, was really the top predator in this forest because the main life form was animals, other animals, and the other animals in the forest mostly were insects, and all the insects were smaller than this guy, so this guy was our top predator and would eat the little mayfly-like insects and the other flies. And now it is time for Arthropleura. Arthropleura is the millipede, and the millipede is amazing. And I see King Potato and a couple others asking about moderators. We are going to be done in about 5 minutes. I've got to finish up soon, and I don't believe we have anyone moderating the chat today, and I really appreciate everyone being friendly and just taking care of it yourself. Thank you. So Arthropleura is this giant millipede. And this millipede was so big that if the millipede was on the ground, and if you were laying on the ground, it would be longer than you. It was fairly flat. Its body was fairly flat, so it wasn't much taller than this. But it was more than 2.5 meters long. That's like a little over 6 feet long, and 1.5 to 2 feet wide. So amazing, so amazing. And I'm gonna choose sort of a reddish brownish color for our millipede, Arthropleura. And if you're totally freaked out thinking that this is like the scariest thing you've ever heard of, I will tell you that Arthropleura was vegetarian. It ate plants, so not to worry there. And it was probably fairly docile, because in this forest, you had the insects going around, you had some millipedes and different bugs, in the leaf litter, but this really was a fairly safe and friendly place. All right, and as I start painting my Arthropleura, I decided that he's just gonna look like a log if I use that color, so I'm changing my mind. Normally, whatever I start with, I just go with it, but I don't want Arthropleura to look like a log, because this is way too exciting of a bug to look like a log. So we are going to do orange instead. I'm gonna get some orange and get a little bit of this red and brown that I was already using, and I'm gonna mix it in with my orange. And then we're gonna try and highlight some of these segments here. Oh my goodness, I feel like brown is just taking over my painting, you guys. Okay, we're doing straight orange now. So much for brown, straight orange. Segment 1, segment 2, segment 3. We're gonna make him have stripes, orange stripes. And then he won't look like he's a log. Arthropleura had these segments, I think about 30 segments on the body. And then it had these little side segments down here. And then underneath there, it had legs. And just like today's millipedes, Arthropleura had a ton of legs. We're talking huge number of legs. And again, if I could go to any forest, you guys, this would be the one I would want to visit. I think it would be so amazing to see these animals and just to see the variety of plants. Although it would not have been super comfortable to visit for long, because 35% oxygen is not what we are adapted to, and that's not the most comfortable of ratios of gas for us to breathe. All right, I'm gonna back up a little bit and we'll answer just a couple questions. I hope that you enjoyed painting a Carboniferous scene with me. Oh, you know what I realized? We totally forgot this log. So down here at the bottom, this is another log. And then on top of that log, if you want, you could draw a bunch of moss, because there would have been moss growing over everything in this forest. There we go. Calling the log done. All right, I'll take just a couple questions. Duck King asks, is there another live stream today? Nope. Two per day is my max. If you had asked me like 4 months ago, hey, would you ever live stream every day? I would have been like, no way. I would have never thought this was possible, but here I am. Vivian says she has a question for Math Dad. I don't know if you guys heard that. That's his answer whistle. That means I heard you. I'm coming.
Hello.
Question for Math Dad.
All right.
Ask real fast. Oh, are those animals called megafauna? Megafauna is sort of a term that refers to bigger animals. So yes, you could call all those insects megafauna. Giant insects.
Wait, how big was this thing?
This thing was like this big. I gotta get wingspan of about this big. So that's how big that dragonfly was.
That scared the bejeebers out of me, man.
Isn't that crazy? Because how big this guy was.
Well, you told me that one was like as tall as me.
Yeah. So if I could pick up that giant millipede and hold it upright, like it would be about, I gotta go about this wide, and it would be like this tall. taller than me.
So is there a painting with a scientist every day?
Not every day. It is Mondays and Fridays going forward. So we'll have it on Monday and we'll have it on Friday. You can start and end your week with science paintings.
Yeah, Science Mom does a lot of prep work for this. The painting part's just fun and pleasure. She actually it's all the behind the scenes work.
Looking up stuff about. All right, I see Hayden asked, can I be a moderator? We don't have any official moderators in here right now, but by just being a good member of our chat, you guys help out a lot. All right, I'm looking for questions.
Was there a math question specifically, or you just brought me in because you wanted to show off your whistle?
Someone said they had a math question. Maybe they just wanted you to sing the song because I'm seeing that.
I'm singing a song.
No song. Are there any animals that eat those insects? No. In the Carboniferous, animals had not developed yet, so there were no other animals. You only had insects eating insects. And then at the end of the Carboniferous, you started to have the first reptiles and birds, but those were not there at the beginning of the Carboniferous. Good question.
Hey guys.
Do you use calculators in school when you went to school? There's your math question.
So actually, we didn't use calculators very much until I got to high school. I started getting into classes where we use a graphing calculator, which you can plot points in the plane and use formulas to actually determine things. And this is a topic that we're going to get to in upcoming weeks. But yeah, when I was in high school, I had my trusty TI-85 calculator, this big old thing. I mean, they still actually sell them, usually a different version, but had nice big pockets. Girl pockets couldn't even fit one of these. They had to have nice big pockets. And I just carried this thing around with me, but I could program on it. And I even had some games on it. I don't know if the teachers knew about that. But,
I have to say, so I didn't know Math Dad in high school, but the thought of Math Dad walking around high school, really proud of his calculator, it just makes me smile. That's pretty cute. All right. Awesome. You guys, thank you so much for being here. And I think someone is saying there they have a pet millipede in the chat. That's awesome.
I'll just say one of these days we're going to do math art. So you'll get to do some art with Math Dad. So I'm not quite the artist Science Mom is, but we'll learn how to draw some things. Maybe we'll do some fractals and some other cool patterns that are mathematically based.
That would be awesome. All right. Thanks again for watching. And I will see you guys tomorrow with another episode of Quarantine.
That's right. What's our topic for tomorrow?
Tomorrow, we're going to be talking about fossils and different types of rocks. And we have a really cool activity where we're going to make some metamorphic rocks. It's going to be a lot of fun. Thanks again, you guys, for watching. Every single person who watches and shares the video, and especially you guys in the chat who are always, trying to help me out with more likes and sharing the video. Super appreciate it. It makes a huge difference.
Do you guys think Science Mom should dye her hair blue?
No.
This is a good look.
I like the wig, but no, I don't want blue hair. All right. Have a good one, guys. We'll see you later.